Hi friends, welcome back to my channel. Padhiye With Prachi में आपका स्वागत है. Welcome one and all. Today is August of 8th, 2024 and I was planning to go live today for the first time on my YouTube channel at 4 p.m. I put on the notifications, I put out the posts, everything. But since I've just started this channel, just launched on August 3rd and I've only 2 of my videos are out. I think only one shorts is also out. So it doesn't allow me to go live right now. It did allow me actually, but it didn't allow me to show my camera, to show myself, to show the whiteboard. So I had done everything, set up everything on my phone here and was all set to go take you through my content of today. But I couldn't, and on phone I was simply not allowed to go live. So I just went on the live and explained that to you guys. So that's enough of the preamble. What I want to say now is I'm going to take you guys through the content I had prepared in this, and this will be uploaded soon. The purpose of this live session is kind of an extra lesson of sorts, and where I can take you through the questions that you guys have asked or I myself want us to practice. It's like a practice class, and I can take your questions in the comment section, or however we can see how we do that when we get there. As of now, I'm continuing with real numbers, and yeah, so let's get into it. Frankly speaking, I was also not very sure as to how am I going to take you guys through the live. What I thought was I'll just display this here and I'll take you guys through it. So I'm just trying to do that right now as well. Okay, this is the setup. I don't know whether you guys are going to see my face also with the kind of setup I've done. I don't think you will, guys. My purpose is कि आपको ये दिखे. Okay. So we are going on the board after a long time. And yeah, you'll just see bits and pieces of my face, I think. It's a little... I'll make it better next time, sorry guys. Okay, so I wanted to take you guys through this concept of Euclid's division lemma. So when we were doing real numbers, and this was something which came into my mind also when we were studying the chapter. It said that there are 2 concepts that we are going to study. One is Euclid's division algorithm, and the other is fundamental theorem of arithmetic. I'm sorry, this is like completely haphazard, but just bear with me. So fundamental theorem of arithmetic is something which I've taught you guys in class as well, and Euclid's division lemma is something I'm going to take you through this. So any of that, what I wanted to say was I'm going to go in the live mostly taking questions from exemplar. What I understand is that for board exams, you need to be well versed with your NCERT textbook, right? You need to be well versed with the NCERT textbooks, the questions, go through all the examples, go through all the questions. Just be well versed with this book completely, and you actually don't need to do this. Having said that, why I'm taking it up is obviously it has a lot of extra knowledge which you don't even need. We'll just go through some questions. It's more for a practice purpose. What happens is that usually if you practice 10, then at least 5 is very much known to you. That's what I see it happening. You guys very well who are like struggling or who are just wanting to focus on the main thing, go ahead and just focus on your NCERT. This is kind of an extra tidbit for people who want to go a little bit beyond. So what you can do is that, so for example, NCERT has 5 questions. You can practice 10, 5 more from this. So when you practice 10, those 5 will become absolutely strong. That's what I used to feel, but it might not be the case for everyone. So you can go ahead and ignore. That's what I'm trying to say. It's a disclaimer on this, but that's just about it, right? So Euclid's division lemma. This is a concept which was mentioned in your NCERT books but not written anywhere. So what does it say? It says that if there are any 2 positive integers, a and b, right? Positive integers a and b, where a is greater than b, then we can express it like this: a equal to qr. What is qr? Sorry, a is equal to bq plus r, where the remainder, what does this mean? Normal, this is a division concept, right? This is a very normal division concept, where you are just a divided by b and you are expressing it in some form, right? So a is bq plus r, right? Now you can use this in a variety of ways, and this is a very important thing. When you're finding HCF of two numbers, so for example we want to find the HCF of c and d, where c is greater than d, what we'll do is we'll express it in this form, which is dq plus r. Now if r is equal to 0, then d is the HCF, right? If r is not equal to 0, then we'll repeat this, we'll express now the d, the second, as right, we'll again divide it by, so we'll divide this by the remainder which is remaining here, right? And continuing this, so for example we have continued and we continue to divide d by the remainders that are coming. So for example this is the nth one, I'm just writing something here, n plus 1, so this is what is coming, and now this remainder is becoming 0. So in that case, this is the HCF. This will become more clear when I'm going to solve certain questions. तभी ज़्यादा clear हो पाएगा, वरना नहीं होगा. So in this class, what my aim is to teach something new, some different type of questions. So we are going to straight away jump to a question which sort of helps us express it. So we have two numbers, 65 and 117. Let's find the HCF by Euclid's division lemma. So how can 117 be expressed as? 117 equal to 65 plus, because 65 2 is greater than this. So 65 plus, what is the difference between this? 52. Now this is the remainder, we have to again repeat. So we have to express 65 now as 52 into 1. What is the difference? 13. Now we have to again this as 13 into, so we know it's 5, so remainder is 0. So this is the HCF. The question says, HCF to hai, the question says that the HCF is actually this, 65 m minus 117. So that means this is equal to 13. So what is m? 13 130, 130 divided by 65, which is 2. So m is equal to 2. This is actually one of the exercise question present in the exemplar. HCF we have done. Now let's do another question which is not linked to this at all. We have just done this by one example. If you need more, we can go through more. As of now, I'm not. Question is, we have to n square minus 1 is divisible by 8, where n is an integer, natural number, odd integer, और even integer. See, even integer तो directly दिख रहा है कि नहीं है, because minus 1 कर दिया. हो भी सकता है. I'm not saying कि नहीं हो सकता है. But for example, if it's 5 square, but it's not an even integer, no? This itself is not. If it's an even integer, then obviously the square of an even integer will be an even number, and if you subtract minus 1 from it, it will become odd. So this is straight away out. Integer तो भाई दुनिया भर के integers हैं. That's straight away out. आंसर आपका यही है, वो देख के ही क्वेश्चन देख के ही लग रहा है, बट यू हैव टू प्रूव इट हाउ इट इज. नेचुरल नंबर भी अगेन इट्स दुनिया भर के नंबर्स. यू कांट से ऑल द नंबर्स आर इन दिस फॉर्म आर डिविजिबल बाय 8, राइट? इट्स क्वाइट इंट्यूटिव. So let's do odd integer. A odd integer is expressed as 2p plus 1, where p is an whole number, not a prime number. If you are confusing with prime number, then I'll just write 2m plus 1, 2k plus 1, whatever. So if we do this, why is my sketch pen going out? So it's the new one. 4m square plus 4m plus 1 minus 1, 1 1 cancel. 4 you will take common, m you will take common, so m plus 1. So 4 is there. Now what is this? m we know these are numbers, right? So these are consecutive numbers. So consecutive numbers का मतलब ये है कि इनमें से एक या तो ये 0 है, तो 0 1 हो सकता है, or it is 1 2 2 3 3 4 5 6 whatever, right? So one of the numbers has to be an even integer, and if one of the number is an even integer, then it has to be 2. A factor of 2 will again come here. So this 8 will be present. So it's divisible by 8. Got it? Okay. Let's do one more question. Now we have numbers 1 to 10, right? So we have number 1 2 3 4 5 6 7 8 9 10. इनका हमें HCF बताना है, right? That's the question, I think. HCF भी नहीं बताना है, HCF कह सकते हो, या the least number that is divisible by all the numbers, both inclusive, is what? See 1 है तो 1 का तो anyways it's fine, ठीक है. So 2 is there, 2 into 3, it's like HCF only, 3, 2 square आ जाएगा इधर. Actually not HCF, LCM. Why was I saying HCF? I don't know. LCM. So इससे ये कवर हो गया, 3 आ गया, 5 आ गया, 6 ऑलरेडी कवर्ड है 2 और 3, 7 आ गया, 8 ऑलरेडी कवर्ड नहीं है तो 2 क्यूब हो जाएगा, 9 आएगा, 3 स्क्वायर हो गया, 2 into 5 ऑलरेडी कवर्ड है. सो दिस इज द नंबर. व्हाट इज दिस? 8 into 5 40 into 9 into 7 40 into 63, 4 3s are 12, 4 6 are 24, 25, 2520. That's the answer. LCM. I don't know why I said HCF. एक और क्वेश्चन करते हैं. आई थिंक विल बी डन विद द डे टुडे. क्वेश्चन इज अ पॉजिटिव इंटीजर इज ऑफ द फॉर्म 3q plus 1. q being a natural number, can you write its square in any other form other than 3m plus 1? That is 3m plus 2, 3m plus 3. That is what's written, right? 3m मतलब ये सब तुम नहीं लिख सकते, तुम सिर्फ इसी फॉर्म में लिख सकते हो उसका स्क्वायर, ठीक है. सो लेट्स सी 3q plus 1 का स्क्वायर क्या है? 9q स्क्वायर प्लस 6q plus 1, राइट. इसमें से 3q कॉमन ले लो, 3q plus 2 plus 1. So this is a number, right? In fact इसको आप ऐसे भी लिख सकते हो, 3q square plus 2q plus 1. So this will become 3m plus 1. और किसी फॉर्म में हो नहीं सकता है. So friends, that was all it was for today. It was supposedly a live session, but it had became a recording. So I'll be uploading this recording soon, and you guys check it out. Let me know if you have any questions in the comment section below. And what else? Like, share, comment, and subscribe to my YouTube channel.